Hi guys, so we've got one more thing to I think this is the last section to talk about involving surface area. So we are talking about surface area of spheres. It is, all of this is coming from section 12.6, or today's topic is basically section 12.6, all right? But 12.6 talks about spheres as a whole, right? I think you guys have been kind of picking up on the fact that this unit that we've done over the past several days is just surface area of all the different types of solids. So the next thing we're going to do after that is volume, right? So section 12.6 talks about surface area and volume of spheres at the same time. So we're only doing the surface area stuff. So if my memory serves me correctly, your homework or your assignment on surface area of spheres should be pretty short, which means this video should hopefully be pretty short. And I think that's everything I have to say about that. Yeah, so if you look in section 12.6 for any like extra materials or stuff like that, we are going to get to volume of spheres eventually, but I would just focus on the surface area stuff for right now. All right. And the nice thing with spheres is, they're balls, right? So spheres don't have any faces. So there is no such thing as the lateral area of a sphere. It's just the surface area. All right. And this is another formula that you guys are going to have to know. The surface area of a sphere is 4 pi r squared. All right? Pretty basic. And I'm sure there's a whole proof on the internet of where that comes from and why it's 4. No one wants to go through that, so we're not going to do it. We're just going to dive right into a problem, and it really should be the easiest thing in the world. The surface area formula is 4 pi r squared. So we're given our radius. So this is 4 pi times 4.5 squared. And then we're just going to simplify all this. If it said like exact answer, like 4.5 squared, that's pretty long. All right, so 4.5 squared is that, times 4 is 81. So again, the exact answer, if this showed up on a review sheet or on a check, would leave the pi in there. So this is going to be 81 pi inches squared. But because this specific question says round it to the nearest tenth, we are going to take that extra step and multiply it by pi. And then I'm going to hit this button down here to round that off. And that gives us approximately 254.5 inches squared. So I feel like I've said this in every single video on surface area. Be careful with directions. Be careful with your units. Be careful with rounding if it does ask you to round. And yeah. So this next one is pretty much the exact same thing. Surface area doesn't change. Or the surface area formula is still 4 pi r squared. So this is 4 pi times 6.25 squared. This might get us a slightly longer decimal. Yeah, so when we multiply this by 4, we're probably still going to get a decimal. So I would still, because this is a relatively tame decimal, if this kind of question did ask you to leave your answer exact, I'd probably like to see this whole thing written out. 156.25 pi. You could absolutely convert this into an improper fraction if you wanted to by using this F to D button, second fraction button. Whoops. That gets you a mixed number. And then this button, the gray right under the second button, is converting mixed numbers to improper fractions. So second and then the button right below it will convert that to an improper fraction. You can do that if you want. You don't have to. But again, this question is asking you to round to the nearest tenth. So if you do, we'll go back to the 106.25 times pi. That is about 490.9 inches squared. Still squared because it's still surface area. All right. Just a couple things that I want you guys to be careful of in these next couple problems. All right. Just like I think the concept of a great circle without all this explanation is pretty straightforward, right? A great circle is of a sphere is basically the circle that goes through the center of the sphere, right? If we think about like the earth, right? The equator is the imaginary line that goes around the center of the earth, right? So the equator would be the great circle of the earth. You know, it kind of looks something like that, right? Like if we consider this the earth, this great circle in the middle would be the equator. All right. The endpoints of the diameter of the great circle are called poles. So there is like a vertical, is that the prime meridian? I can never remember what that one's called. The equator goes around horizontally. And then there's another imaginary line that goes from north to south that passes through the north and south poles. I'm pretty sure that's called the prime meridian. I don't know why I can never remember that. But poles are pretty self-explanatory if you think about like the prime meridian and the north and south poles and stuff like that. So that's that. Since a great circle has the same center as the sphere and its radii are also radii of the sphere, it is the largest circle that can be drawn on a sphere. So like you could kind of figure this out. I really like to use like latitude and longitude. The whole latitude and longitude analogy to make sense of it. Sorry, I just lost my train of thought for a second. So like, the other lines of latitude and longitude would be shorter, I guess, than the equator and the prime meridian. All right, that's kind of what this is saying. The great circle doesn't necessarily have to be horizontal. It can be in any direction as long as it passes through the center of the sphere. And its measurements and all of that, you know, the radius of it and the circumference in the area is the biggest, you know, in the entire sphere. So when we talk about cutting a circle in half, we're cutting it via the great circle, right? The radius of the great circle is actually the radius of the entire sphere. So we can use that information when we talk about hemispheres in a little bit, which is just splitting a sphere in half. All right? Because when we talk about surface area of a hemisphere, we do have to take some of that into consideration. If this is the formula for the surface area of a whole sphere, half of a sphere, the surface area of half of a sphere would just be 4 pi r squared divided by 2. So it's just going to be 2 pi r squared. But if we're splitting it in half, you do also have to think about that great circle on the bottom. That is still exposed surface area. So we're not only doing half of the sphere, but we are tacking on the area of one extra circle on the outside on the bottom. So we just actually kind of have to tack that on another pi r squared. So it's actually not 2 pi r squared. We can combine these two because they're like terms. It's going to be 3 pi r squared for the formula of the surface area of a hemisphere. That might be something that already exists on the internet. But I do just want to make you guys aware of that when you're finding the surface area of a hemisphere. If you have like a whole hemisphere, none of this is making any sense. I'm so sorry. You guys know, if you have any questions, definitely reach out. When you cut a sphere in half, if the surface area is 4 pi r squared, cutting 4 pi r squared in half is going to get you 2 pi r squared. That makes sense. But this circle on the bottom is still part of your surface area. So you have to tack on another pi r squared, which is a formula for the area of a circle. So 2 pi r squared plus 1 pi r squared is 3 pi r squared. I don't think this formula is anywhere in the book, which is why I didn't put it in. It might be somewhere on the internet. If it is, great. If it's not, just remember all of this that I'm saying when you go about these problems. Okay, so now I think our lives are going to be a whole lot easier because we have this formula and we have the radius, and we're just going to plug it all in. So 3.7 squared is that, times 3 is that. So it doesn't say anything about rounding, so I'm going to leave this as the exact answer, 41.07 pi millimeters squared. That's the surface area. All right, so let's do this again without me rambling. So the surface area of a hemisphere would be half of a sphere, right? So it would be not 4 pi r squared, but 2 pi r squared. But we do have to take this circle on the outside into consideration as part of our surface area. So we tack on another pi r squared, which means we get 3 pi r squared. And now we can plug it all the information in. 3 pi times 4.2 squared. All right, so that, again, exact answer is 52.92 pi millimeters squared. Okay. So find the surface area of a sphere if the circumference of the great circle is 10 pi feet. All right, so one of the things I had mentioned before was the fact that the radius of the great circle is the radius of the sphere. All right, so we know the circumference of a circle is 2 pi r. And since we have the circumference, we can use the circumference to find the radius and then use the radius to find the surface area. That's what we're doing here, basically. So 10 pi is equal to 2 pi r. So the radius is 5. That's pretty straightforward. And then we're going to use that 5 to plug into the surface area formula. So the surface area is 4 pi r squared. So this is 4 pi times 5 squared. So that's 100 pi feet. Cool. If there are shortcuts, like I don't know if there are shortcuts on the internet about how to relate the circumference of the great circle to the surface area of the sphere. Again, it doesn't show up in this textbook. That's why I'm not using it. If you find anything, you don't have to go out and looking for it because I think this kind of long way of doing this is pretty straightforward and is pretty easy to figure out. But there might be things on the internet. I don't know. You guys are resourceful. You can look it up if you want to. Okie dokie. So find the surface area of a sphere if the area of the great circle is approximately 220 square meters. So we are going to have to do a little bit of rounding here. So again, the radius of the great circle is the same as the radius of the entire sphere. So we're just going to use the regular area of a circle formula. And we know that this is approximately 220. So I'm going to try to keep as much of this in my calculator as I can. 220 divided by pi is approximately that, about 70. But then I'm going to leave this again in my calculator and take the square root of the answer to get the most exact answer I can. So the radius is approximately 8.37. All right. There's no requirements for rounding, so we're just kind of go with it. All right. What was I going to say? Oh, so then we just do surface area. So surface area is 4 pi r squared. So this is 4 pi times 8.37 squared. I'm going to move this up a little bit. So again, I'm going to leave this in the calculator. I'm going to square this, which kind of just undid when I just took the square root of it. So you're going to get the exact same approximately 70. And then multiply that by 4. For something like this, because the numbers are so weird, I probably would never ask you to leave the exact answer. But if you wanted to leave it in terms of pi, it would be approximately 280.1 meters squared. We've been rounding to the nearest tenth the entire time, so I'm just going to keep that consistent. Or if you wanted to do like the full thing, rounding the whole thing to the nearest tenth, you would have to multiply it by pi. Oh, and look at that. That actually gets us really nice answer. I forgot to put the pi in there. All right. So it's 280.1 pi approximately, or exactly 880 meters squared. Nice. That might actually be better then. Okay. So there you go. That's the entire lesson on surface area of spheres. Ooh. All right. Before I go, I'm pretty sure this weekend is Memorial Day weekend. So, we are going to treat it like it's a day off from school on Monday, right? So you're not going to get any work from me or any assignments from me for Monday. All right? So definitely enjoy the weekend as much as you possibly can with social distancing and all of that. Hopefully it's going to be really nice this weekend. I hope. I'm not 100% sure. And I think that's it. I think I've rambled enough. Talk to you guys soon.